Next topic of notes is determinants. The determinant of a 2 by 2 matrix. This is matrix B. So, if we were to write that we wanted to write the determinant in a symbolic form, it would look as such. We would have 2 vertical lines on either side, and this just means determinant of matrix B. And so, how would we find it? You would take first this diagonal, 5 times 4, and then you minus the other diagonal, which is 3 times negative 1. And so, we know that 5 times 4 is 20. And we're going to minus it. And we know that 3 times negative 1 is negative 3. But we know that when we're subtracting negatives, we add them. And so, 20 plus 3 is 23. And that is your determinant of matrix B. That is all you have to do. So, what are determinants used for? Well, determinants tell us things about the matrix that are useful in systems of linear equations and help us find the inverse of a matrix. So if you wanted to write that down just to note it, I'll write it here. I'll just bullet point it. So it's used for systems of linear equations and also inverses or inverses, however you would say that plurally. It would be inverse of a matrix. And that's what determinants are used for. So if we were to do practice problems, let's do matrix C, and it equals to negative 1, 0, 2, and 2. This is matrix C. So what is the determinant of matrix C? Matrix C. We would do the first diagonal, which is negative 1 times 2. And we're also going to minus these diagonals. So that's up. And we're going to do this diagonal, which is just 0 times 2. And so we know that 0 times 2 is just 0. And we're minus this, right? And so, negative 1 times 2 is just negative 2. So negative 2 minus 0 will give you negative 2. And that's the determinant of C.
Moving on to the inverse of a matrix. For matrix A, which is a 2 by 2 matrix, the inverse is seen as A with a negative 1 in the exponent. Whenever you have a negative 1 in the exponent, you can understand that it will be an inverse. When A is multiplied by the inverse, the result is the identity matrix, which is seen with a capital letter I. What is an identity matrix? An identity matrix has the same number of rows and columns it has a number 1 in every spot going diagonally, starting from the upper left to the lower right. Lastly, a 0 is put everywhere else. This is how you get an identity matrix. You're probably wondering what this would look like. It would look like an A with a -1 in the exponent for the inverse equals a 2 by 2 matrix with a 1 in the upper left and a 1 in the lower right. So you have that diagonally. And a 0 is put everywhere else, like this. So now you have the 1, 0, and the 0, 1. This is a 2 by 2 identity matrix. Continuing from our last notes, formulas for calculating the inverse of a 2 by 2 matrix. We know that a matrix looks like this. The inverse formula looks like this. This is your determinant. Multiplied, so your determinant multiplied by your inverse matrix. So for your D and your A, they're switched, as seen here, your A and your D, now they're switched, D and A. Now for your B and C, they stay in the same place, but they turn negative. So, your inverse formula is your determinant, which is a single real number that we learned in our last notes, multiplied by your inverse matrix. Today we will be solving matrix inverses. We are given this matrix. First we have to find the determinant. So -3 multiplied by -2 minus -4 multiplied by 2. This comes out to 6. Bring down the minus sign. And this comes out to -8. A negative and a negative make a positive. And our determinant is 14. Note that when we find determinants, we always subtract. Now we take our determinant which is a single real number, and put 1 over it inside of the A inverse formula. For this matrix, we take our original matrix and switch the A and the D. B and C are now negatives. And now we solve. Note that we can simplify our solution. Now we will be finding the identity. We take the matrix A, our original, multiplied by A inverse, note that we are simplifying here from here to here. And now we will get our identity here. So the first row multiplied by the first column is how we did our A. You should already know how to solve for multiplying matrices in our last video. So I will continue to solve it. We will get our identity by adding all of these. So 3/7 plus 4/7 equals 1. Negative 6 over 7 plus 6/7 equals 0. And so forth. This is